An asteroid hurtling towards the Earth is something real-life scientists are preparing for at NASA.
Imagine waking up to the news that an asteroid the size of a skyscraper is hurtling towards Earth, and it's set to impact in just a few weeks. This isn't the plot of a Hollywood movie. It's a real and imminent threat. Welcome to our special report on Apophis, the asteroid that has captivated scientists and the public alike. Today, we delve into the startling revelation from Cern and what it means for our planet. It all began in June 2004, when astronomers Roy Tucker, David Tholen, and Fabrizio Bernardi were conducting routine observations at the Kitt Peak National Observatory in Arizona. During their search for asteroids, they stumbled upon an object that would soon become infamous. Named after the Egyptian god of chaos and destruction, Apophis quickly caught the attention of the scientific community. Initial calculations of Apophis's orbit were alarming. The asteroid, measuring approximately 370 meters in diameter, was predicted to have a significant chance of impacting Earth on April 13, 2029. The potential for such a catastrophic event sparked widespread media coverage and fueled public fear. Scientists estimated that the impact could release energy equivalent to over 1,000 megatons of TNT, causing unprecedented destruction. Over the years, NASA and other space agencies worked tirelessly to refine their calculations. By 2006, they had gathered enough data to reassure the public that the likelihood of an impact in 2029 was extremely low. Apophis would pass close to Earth, but it would be a spectacular yet harmless sight in the sky. However, the asteroid's journey was far from over. Fast forward to today, and the situation has taken a dramatic turn. Cern has announced that Apophis is now on a collision course with Earth, with impact expected next month. This shocking revelation has sent shockwaves through the scientific community and the public. But what led to this sudden change in Apophis's trajectory? Asteroids are small, rocky objects that orbit the Sun. They are considered to be leftover building materials from the early solar system, over 4.6 billion years ago. During the formation of the planets, not all of the material was incorporated into planets or moons. The remaining bits and pieces became asteroids, and they provide valuable clues about the early solar system's conditions and processes. Asteroids follow elliptical orbits around the Sun, similar to the orbits of planets. However, their paths can be influenced by gravitational interactions with planets, especially massive ones like Jupiter. These gravitational forces can alter an asteroid's trajectory, potentially sending it into a collision course with another object, such as Earth. Apophis is a particularly noteworthy asteroid due to its size and trajectory. Discovered in 2004, Apophis is approximately 370 meters, about 1,210 feet, in diameter, making it large enough to cause significant damage if it were to impact Earth. Its close approaches to Earth have made it a subject of intense study and monitoring. One of the reasons Apophis has garnered so much attention is its series of close approaches to Earth. In 2029, Apophis is expected to pass within 31,000 kilometers, 19,000 miles of our planet, closer than some of our geostationary satellites. This close encounter, though predicted to be harmless, will be an extraordinary opportunity for scientists to study the asteroid up close. Although the 2029 pass is not expected to result in an impact, the future trajectory of Apophis is still being closely monitored. Gravitational interactions during its close approach could potentially alter its orbit, making future impacts possible. This is why scientists are vigilant in tracking its path and refining impact probability estimates. If Apophis were to hit Earth, the consequences would be devastating. The immediate impact would create a massive shockwave, destroying infrastructure and causing widespread fires. The environmental aftermath, known as an impact winter, would see dust and debris blocking sunlight, leading to a dramatic drop in global temperatures. This would disrupt weather patterns, cause crop failures, and lead to food shortages. The long-term effects on ecosystems and human life would be profound. Efforts to mitigate the threat. In response to this looming threat, scientists and engineers are exploring various techniques to prevent the impact. One promising method is kinetic impactor technology, which involves sending a spacecraft to collide with the asteroid, altering its trajectory. NASA's Double Asteroid Redirection Test (DART) mission is an example of this technique in action. The threat posed by asteroids is a global concern that requires international collaboration. No single country has the resources or expertise to tackle this issue alone. Hence, space agencies around the world are working together to develop and implement strategies for detecting, tracking, and potentially deflecting hazardous asteroids. The European Space Agency, ESA, is playing a key role in planetary defense with its HERA mission. HERA is part of the larger AIDA, Asteroid Impact and Deflection Assessment, collaboration between ESA and NASA. HERA is set to follow up on NASA's Double Asteroid Redirection Test, DART, mission, which aims to demonstrate the kinetic impactor technique for asteroid deflection. DART mission. DART's objective is to collide with the smaller body of the binary asteroid system Didymos, known as Dimorphos, to change its orbit. This will test the effectiveness of using a high-speed impact to alter an asteroid's trajectory. HERA mission. Scheduled to launch in 2024, HERA will arrive at Didymos in 2026 to study the aftermath of DART's impact in detail. It will gather crucial data on the resulting crater, the composition of the asteroid, and the changes in its orbit. This information will help scientists refine models of how kinetic impacts can be used for planetary defense. Another innovative approach to asteroid deflection is the use of gravity tractors. This method involves placing a spacecraft near an asteroid and using the gravitational attraction between the two objects to slowly alter the asteroid's path. The gravity tractor doesn't physically touch the asteroid. Instead, it hovers near the asteroid, using its thrusters to maintain a stable position. There are generally two types of nuclear strategies for asteroid deflection. 1. Nuclear explosive device, NED. Detonating a nuclear explosive device near the surface or beneath the surface of an asteroid to impart a significant force, changing its trajectory. 2. Nuclear standoff explosion. Detonating a nuclear device at some distance from the asteroid to vaporize part of its surface. The resulting recoil force from the vaporized material can push the asteroid off course. The use of nuclear devices poses significant risks, including the potential for fragmenting the asteroid into multiple pieces, each on a collision course with Earth. Additionally, international treaties and public concerns about the use of nuclear explosives in space add to the complexity. The threat of Apophis underscores the importance of advancing our space exploration efforts. As we face the imminent threat of Apophis, it's clear that our efforts in planetary defense and space exploration are more important than ever. The collaborative efforts of scientists, governments, and the public can make a difference. Together, we can rise to the challenge, protect our planet, and ensure a safer future for generations to come. Thank you for joining us on this journey into the heart of one of the most pressing challenges of our time. Stay tuned for more updates, and remember, knowledge and preparedness are our best defenses against the unknown.